factor theorem, remainder theorem, and division algorithm. Okay, factor theorem, remainder theorem, and division algorithm. So, right, we need to know these three well, right? Okay. So, what is the factor theorem? What's the remainder theorem? That's the first thing I need to ask there. Right? If we need to get the remainders when polynomial divided by another polynomial, right? Okay, it is we call the right. Okay, what is remainder theorem? How we get the remainders and how we find the factors, right? But only we know to find the factors of quadratic functions, equations, right? But now here we come to the cubic or right other polynomials. Then we need to know how we get the factors there. Right, that's the area we covered here. Okay, then right, then we need to know right these things here. So under the right factor theorem and the remainder theorem. Now we come to the remainder theorem. Then here we use the log division early. Right, the first lesson we have a log division. Can you remember that? I know that. You know it very well. Right? Right. Here we have right log division. Then right, if they are given any linear or quadratic or any other thing to divide and find the remainder, then we can follow it. Next, right? Then especially right, if we get like this, x cubed plus 2x plus 3 divided by x minus 1. So how will we get the remainder? X cubed 2x plus 3 divided by x minus 1. So we follow the log division. X cubed plus here we write 0x term because they have missing term, right? Then x minus 1. Now we get the x cubed divided by x. It's x square. Next, x cubed divided by x, right? Leading term of the division, right? Dividend, leading term of the division, and divide that too, right? Then we can get the first term of the quotient. Then x square times x cubed, and the x square times that minus x square there. Then you get the subtraction, which is x square plus 2x plus 3. Now again x square divided by x, it's a x, and the x square minus x here, subtraction 3x plus 3. So whatever, we put the 3x minus 3, right? Subtraction is 6. Then that's the remainder. Okay, that's the remainder. Then let's get like that. Then I get the fx equal x cubed plus 2x plus 3. Now here we have a divisor is x minus 1, then it's equal to 0, then x equal 1. Then what happened? Now I substitute that 1 to here, f1. That's mean x equal 1. Okay, then all x be 1, 2 times, right? 1 plus 3. What happened? 1 plus 2 plus 3, it's a 6. Right? Okay, so what happened? Here we have a remainder 6, here we have a remainder 6. Right? Number 6. Right? Then here we have some relation. Okay, what's the relation? Here we have a function fx. It's divided by the x minus 6 type of linear one. Then this is a dividend, this is a divisor. Then divisor equals 0. The value of x is a. Then we substitute that a to the function fa. That means x equal a, substitute to there. That's why x be a. Right? Then fa be a remain. Okay. That is we call the right remainder theorem. Remainder theorem. Then, however, we find the function divided by a linear one, right? They are remainder. However, we substitute, right? That we right divisor, right? Divisor equal to 0, they are x value to the function. We can find their remainder like 6 is a remainder, and here we have 6. Okay, right? Then like that, right? We can follow the right remainder theorem. Okay, it's a remainder. Right? Okay. Then what happens next? Factor theorem. How we find the factors? Right? How we find factors? Right? Then first thing, what happens if we divide by the function by their factor? Right? The factor means it can be right fully right multiple of that. Okay? That's mean what? There remain to be a 0. If we divide by the factor, their remainder need to be a 0. Then under the remainder theorem, we can say what? F of A, right? Then if we have a function, right, then it's divided by the x minus A. Then f A is a remainder. Then that remainder be a 0. We can say x minus A is a right factor there. Okay, right? Then how will we identify factors now? Right? Okay, if they have a cubic or any other thing, right? We get the function and substitute some value, right? To it, it's be a 0. Then we say x minus a, right, is a factor, right? Is a factor, right? That's the way I find factors now, right? Okay, no any other thing. Okay, then, right? Got it? That is we call the factor here. Very easy, right? Very easy. No any other thing, right? We need to right get some values, but here we have some right constant values to substitute because otherwise, right? If we need to substitute, right? Okay, what happened? Right? If they are given the function, right? X minus 1000 is right factor. Then, however, we find the 1000, right? How we imagining? On. Then, so they have right 6 things. Then A can be minus 3, minus 2, minus 1, 1, 2, and 3. Then one of these, right, we substitute. Definitely that question, right, goes to 0. Right? That's the way, right, they are given the, right, okay, pathway. Okay, right, pathway. Otherwise, we can't get it. Okay, then only we need to substitute that's it. Then one of that given the 0, then we can combine, right? Then we need to get the other factors, then we can use the long division method, right? And the other things, right? Let's see the right theory part. Okay, right? Now, right, you need to follow these, right, in the next day, right? Okay, remainder theorem and the factor theorem. Very easy, right? No any hard things there, no any right magics there. Okay, right? Then under the theories, right, we need to follow this one. Right, then we have many more questions there, right? Okay, then we have right, many more things to read, right? But under that base. Okay, then, right now, right, that's the review, right? That's a trailer of first, second list, right? Okay, that's a trailer of second list, right? Okay, now you can get the understanding, right? How we get the remainder, how we get the factors. Okay, right, then let's see, right? Let's see what happened. Okay, see.
Minus 2x squared plus 2x plus 3 divided by x minus. Get the remainder there. Now we get x cube divided by x. It is x squared. X squared times x cube, x squared times minus 1 minus x squared. Then divide by it is a fraction. X cube, that's minus 2x squared minus x squared minus 2 minus 1, right? It is minus x squared. Here minus x squared divided by x minus x minus x minus x squared minus x squared minus 1. Fraction 2 minus 1 is x plus 3 x minus 1 of this 4. Now we can identify the remaining. Remaining is 4. Okay. Now, if we get the function f x equal to minus 2x plus 2x plus 3, and I need that f1. F1. Who is F1? It's equal 1. Okay, right? It's equal 1. Okay, let's get that. Then let's get the F1. Minus 2 plus 2 cancel. It is a 4. It is a 4. We got the next one. 2x cube minus 3x squared. Okay, complete divided by 2x minus 1. Okay, right? That is what? 0. Right. Divided by 2x minus. We get the long division. 2x cube minus 3x square plus x plus 3 divided by 2x minus 1. Okay. Divided by 2x minus. Whatever. 2x cube divided by 2x is 2x square. 2x square. X square, 2x, 2x cube, x square minus 1 minus x square. Subtraction minus 3 minus 1. Then this minus 2x square plus x plus 3. Now minus 2x square divided by 2x is not 2x. Plus x, then minus x square is 2x minus 2x square plus 3. Now same answer answer is 3. Next, right? This. Now we get a function is f. The 2x cube minus 3x square plus 6 plus 3. And now I integrate f half. F half. Okay. Maybe f half here. Let's see what happens. Then we get 2 times half cube, 3 times half square, half plus 2 times 1 over 8 minus 3 times 1 over 4 plus half plus 3. Then 1 over 4, 3 over 4, and we can get the common denominator, doesn't matter. 2 over 2, right? Multiplied by 4, 12 over. It is 12, 14, 15 minus 3, get 12 over 4 is 3. Okay. Now what happens? Now, if we divide by x minus 1, if we divide by x minus 1, we substitute 1 here. The answer is 4, and remainder is 4. Okay? Answer is 4, and remainder is 4. Right? We also divide by 2x minus 1. Answer is 3, remainder is 3, and we substitute x half, then answer is 3. They have some relation. Okay? Then how I get x minus 1? Right, 1 here. X minus 1 equal to 0. X equal 1. Then we have a divisor. Then that divisor equal to 0 and x value. That x value is absolute to the function. We have a value. That value is same for the remaining. Here also 2x minus 1. Then 2x minus 1 equal to 0. 2x equal 1. X equal half. That half is absolute here. You can see the answer. Then that is the call. Right? That is the call. But any polynomial matrix, divide by linear 1 x minus a. A is a constant. Right? A is a constant. Then any polynomial matrix divide by the equals. Then it says what is the remainder? Remainder equals F A. Right? F A. Who is A? This divisor equal to 0. That value is absolute to the function. We can get the remainder. It is we call remainder. Any polynomial left divided by any polynomial left divided by x minus a. Here A is real constant. Here A is real constant. Then the remainder is F A. Right? Any polynomial left divided by x minus a. Remainder is F A. Right? That is the remainder. Okay. Now we come to the proof. Okay. What we need to get fx divided by x minus a. We need remainder. Okay. Then how we write the relations of that? How we write the relations? Fx divided by x minus a. Then we need the remainder, right? The first part, right? Starting, we write the relation. What? Dividend equal divisor times quotient plus remain. Then who's the dividend now? Dividend is fx, right? Divisor is minus a. Then we write the relation x equal x minus a. Then we get the quotient is q x. Is the remaining. Now we need get what number it is x equal a. Then we substitute, right? X equal a. Okay. Then fa equal a minus a qa plus what number a minus 0. Then 0 times qa 0. Then entirely cancel. Right? Here we have fa equals r. Who is r? Therefore, remainder equals okay, right? Now, when we have any function divided by x minus a, then we can get the limitation. Okay? Then fx divided by x minus 1. Fx divided by x minus 1, what will remain? X minus 1. Then x minus 1 equal to 0, x equal 1. Then f1 is the remaining, right? Fx divided by x minus 2, f2 is the remaining, right? Fx divided by x plus 3, f minus 3 is the remaining. Okay, now second question. Find the remainder when fx equal x cube plus 3x square minus x minus 2 divided by, right? They have x plus 2. Okay, right. Then we need to get here we have function fx is x cube plus 3x square minus 6 minus. So they have 5 users. Then we need to get the remainders. Right? First one is x plus 2 divided by x plus 2. Okay. So first thing is we write the theorem. X divided by, okay, here you can write like that. Okay, if x divided by, right? X plus 2, remainder is minus. Okay, this is the right here. Now, we write fx equal x cube plus 3x minus that. Then x minus 2 minus 2 cube. 3 times minus 2 square minus 2 minus 8 12 plus 2 minus 2 are 3. Right? 4. Right? There we say that is 4. Right? Okay, then equal 6. Right? Okay. Then it's here 4, right? Minus 1. Okay. Let's divide by x minus 1. Who is the and get the value. Okay. Now we can say fx divided by x minus 1 remainder is f1. Remainder is f1. Okay. Now fx equal x cube plus 2x square minus x minus 2. f1 equal 1 plus 2 times 1 square minus 1. Now 1 plus 2 minus 1 minus 2 is right. 3 square 3 here, right? 1. Okay. Therefore, we can write remaining equal 1. Then last one, fx divided by 3x plus 1. So we can write remainder equal f minus 1 over 3. Okay. Then f minus 1 over 3 minus 1 over 3 cube 3 times minus 1 over 3 square minus 1 over 3 minus 1 over 3 cube 27. 27. 3 times 1 over 9 plus 1 over 3 minus 2. Now the common derivative is 27 minus 1 plus 3 9 or 27. Here 9 times 9 over 27. 27 times 2, 54 over 27. Okay. Now what happens? Here we have 54 minus 10, 18 plus. It is minus 37 over 20. The remaining equals minus 37 over 27. Okay. Here we have fx equal x cube plus ax plus x minus. Fx equal x cube plus a square plus x minus 1. Now here we have 1. We have 1. Now it's not. Find the value of a. Now we need to get a value. Find value of a. Right? If fx divided by, then you have root 1. Fx divided by x plus 1. Fx divided by x plus 1. Right? Remainder is given minus 1. Okay? Now they are given a value. Okay? But if we need to get the unknown, then we need to create what? We need to create equation. Okay? If we have an unknown, then we need to find that unknown. We need to get equation. Okay? Number of right unknown equal to the number of equations. Now we have one unknown, we need to get one equation. So how we do that? Right? Okay, we need to use the given data. Okay? Now if there says fx divided by x minus 1, what is the remainder? Okay. Now we know to write the remainder using remainder theorem. What is by the remainder theorem? Remainder is f1. Next f1. Right? By the remainder theorem, what is the remainder? F1. Next, now remainder is f1. Then it's equal to what? It's equal to the given value. Minus 1. After that, we get the equation. Here x plus 1. Divided by x plus 1. Then it is f minus 1 equal to minus. Okay, why is here minus 1? It is given. Next, they are given, what is the remainder? Right? If they are given the remainder, then what we need to do? We need to create the equation. However, right, we write what is the remainder? Right, by the remainder theorem, it's equal to the given. Okay, now we have f minus 1, we can replace this minus. Okay, right, then we get the minus 1 here, minus 1 cube, a times minus 1 square, minus 1, like that. Then f minus 1 here, right, minus 1. Okay, right, then here is given, next what happens? Then what happens? Minus 1 plus a, right, minus 1 minus 1, then minus 3 plus a equals minus 1. Now a is what? A is 2. Right, a is minus 3, right, take to the left side, is plus 3 minus 1 is plus 2. Then a equals 2, right, happen fx divided by plus 1 divided here minus 1. Okay, like that, what happens? We can create the equation. Okay, they are given this function divided by that. What is the remainder? Then we get what is the remainder by the remainder theorem, and it's equal to the given right. Fx equal, right? Fx equal 2x cube a square plus bx minus now what? Now the first question given fx divided by x plus 1 then x minus 2 remainders are 0 and 9. Okay, now they are got two remainders. Okay, because if they have one more, then we need to give the two remainders. Now they have two remainders. Okay, then how we write it? We can write fx divided by x plus 1 and x minus remainders are f minus 1, f minus 1 is 0. F2 equal, and we can get the 2 data. Okay, now we can substitute. Give it a minute. Now we have f equal to q plus a square plus bx minus 1. Now it's given. It's equal minus 1. Okay, it's equal minus 1. We have a minus b equal a. Okay, right? And we substitute x equal, right, 2 because the minus x equal 2. Okay, right side. Okay, right side we have x equal again minus 1. Okay, it's equal to 2. Then f2 equal, right, 2 equal 2 times 2 cube 4a plus 2b minus 1, right? Whatever. Here 15 h, that is equal 16 plus 4a plus 2b, right? Minus 1. Okay. Now we have 50 plus 4a plus 3b, 2b is 9. Then minus 6 equal 4a plus 2b divided by 2. 2a plus b equal minus 3. There we say. 2a plus b equal minus 3. We have a plus b equal, right, 3. So minus a equal b is first equation, and second equation is 2a plus b equal minus. Okay, now by the end, by the end. Now what happens here? Minus a plus b, and plus 2 equal 3a equal 0. A equals 0. Therefore, by 1 minus b equal 3, b equal minus. Now here we have a question. Let fx equal x squared minus 2x minus 6. Right? Fx equal x squared minus 2x minus. Find f minus 1 and f3. There are f minus 1 and f3. These one. Okay. Right. Now we can get fx equal, right, f1 is 1 square minus 2 times 1 minus 1 minus 2 minus 3. Right, minus 1. Minus 1 square minus 1. Then is C. Right now, write the answer. It's here C. Right, it's here C. Now like that we get F3. F3 equal 3 square minus 2 minus F3. That 9 minus 6 minus C. Now we have it's here C. Now it says fx divided by x plus 1. Fx divided by x plus 1. So that fx equal x plus 1 times x minus 2 plus 1 times x minus 3 again over. Right now, when they have a case to long, right? Now get long division. Fx need to divide by x plus 1. Let's see what happens. Now what is the remainder we get? In the long division, what is the remainder? 0. Then because why? And we get f minus 1 d. Now fx need to divide by x square minus 2x minus 3 need to divide by x plus. Okay. X square divided by x is x. X times x square. X times 1 plus subtraction. Minus 3x minus 3x divided by x minus 3. Minus 3x minus 3 c. Okay. Now remainder is c. Let me know it. Okay. So here also we get remainder. Okay. We substitute something and get the value, then it will remain. And I find what the is last one. Right? Now what? Here we have remaining 0, how we write a function? Fx equal to what? X plus 1 into x minus 2. Why is that? Beginning we write dividend equal divisor times portion plus remainder. Okay. Now x plus 1 times x minus 3 plus c. Okay. Right? Then that is the way we show the x equal x plus 1 times x minus 3. Okay. Now here we have another one. Here we have another one. Okay. Fx equal 2x cube. Fx equal 2x cube plus x square minus 13x plus. Now if they ask F2, if they ask F2, right? Now substitute F2 is what? And it says divided by x minus 2. Fx divided by x minus 2. Right? So that fx equal to multiple of that. Okay, then so let's see what happens now. Right? Now what happens? 2 times 2 kilo, 2 is square, 15 times 2. 8 times 2 is 16, 4, 26, 26 minus 26. Now again, we have right, 0, 0. Okay. Then we know remaining equals 0, 1. Remaining equals 0, who is that? Easy. That is minus is a reason that needs to be a factor, right? Because if we divide by the factor, they are remaining be C. Otherwise, it may not be C. Okay? Then let's see what happens. Now we divide by x minus 2, right? 2x cube plus x square minus 13 is 6. Now 2x cube divided by x, 2x square, 2x square times x, 2x cube, 2x square times minus 2, minus 4. Subtraction 5x square, 13x plus 5x square divided by 5x. Right here 5x square minus 10x. Subtraction minus 3x plus 6, minus 3x divided by x, minus 3, here minus 3x plus it's 6. Okay. Now we have fx equal x minus 2 times 2x plus 5x minus 3. Okay. So we can get the factors of this one normally, then we can get the factors. Okay. So however we get the factors of the right quantity like that? Yes. How we get the quantity right factors like marginal x square term and constant. Then after 2x square and minus 3. Then here we have a minus 6 square. Then we get the factors of minus 6. Their addition need to be middle, right? Okay, so 2 times 3. 2 times 3. 2 times 3, then here we have minus value. One of that will be a minus. Okay, so one of that be a minus. The addition will be a right? 1. So 6 and 1. Then 2 be a minus. 6 over 1. Then your addition need to be a plus. Okay, now how will we get the factors? X minus 2, 2x square plus 6x minus 6 minus 3. We need to divide 5 into 2 parts. Okay, now x minus 2, here we take out 2x, x plus 3, here we take out minus 1, x plus 2. Now what happens? Here we take out x plus 3 now. It is x plus 3 times 2x minus, right? That's the way we get it, right? Okay, now what happens? Here we divide by one of the factors, then we can get their other factors. Okay, using normal factorization. If they have factors, then we can follow the normal factorization. Then, right, then they have already, then they have two parents. They have a unit, they have a parents. But someone else that who is, first of all, we get a value C was expanded. Then, right, we get value C or when we substitute something here. Right, here also. Then, but now it's given. Then, so if we can identify the number like that in any function, then we can go to the function. Then, right, okay, then that thing is we call it factor theorem. Right, that thing we call it factor theorem. But we have a function, then we substitute some value to the function, that function value be a zero, remain be a zero. Then we can say what is the here if minus 1 is 0, then what is the fact? X plus 1. Right? And also x minus 3 also happens. Then when f3 equals 0, x minus 3 is a then we can say if a equals 0, if a equals 0, then x minus a is because here we have anything, it's multiplied by x minus 5 then minus 1 and minus 1 x. Here we have 3 minus 3 x minus. Then we have a equals 0. We can write x minus a is right. Okay, that is we call fact. Okay, right, right. Okay, on to the right on page. Right. Okay, here we have second theorem is factor theorem. Is factor theorem. Right. Any polynomial f, any polynomial f if a equals to 0, if a equals to 0, if a equals to 0, then x minus a is a factor. X minus a is a factor. Where a is a constant. Where a is a real constant. Right? Okay. Right. That's the thing. Right? Okay. What if we have a function, then we can identify the value. Right? There remain to be a 0. Then we can say they have a factor. Next, right? Okay. Then if 3 equals 0, if 3 equals 0, x minus 3 is a factor. Okay, like that. Okay, okay. Now, if there are given function like this, okay, then we need substitute values. That is substitute values. Okay, 0 के बाद दादा के 0 है, right? Right? वहाँ पर क्या 0 है, right? Yes, and we substitute any other value, right? Now they are better, right? It's not be then there are a function, right? Then we need to weigh the upward. Next, then we need to up to 1, right? 2 be okay, 2 be 0. Then there are given function, they have factor x minus 10, right? Factor is x minus 10, then it is up to 10. Then how many numbers before we up to 9, right? What number? Huh? Question given in detail. Huh? X minus 10 is the factor, and we factor I need to use the factor theorem to get that. Huh? How we identify x minus 10 is the factor. Next, because next, substitute the value, then the value, so let's substitute the value. Okay, right? That's decimal values of then half of it, right? Okay, right? We have right? Therefore, okay, we need to know, right, values of a in here, right? No, right? All values we taken in. Okay, now syllabus they make question, right? Involving that factor, right? Okay, we need substitute. That's it. Minus 8, minus 2, minus 1, 1, 2, and then If they are given factorization question, definitely one of them given the C. Okay, then one factor we get, how we get the other? One factor we find, how we get the other? Using law of division, right? Using law, right? Then we can get the right. One of them need to get it. If they are not says only use right remainder theorem, then we can get one factor by the remainder theorem and others in the normal. Okay, but it says right only using remainder theorem, then we use house and anyway. Then they also given the values, right? Okay, okay, right? Okay, right now they are A here, right? They are A here, they are A here, -3, -3, -1, 1, 2, and 3. Okay, right. Okay, that's the way. Okay, that's the way. Right now, however, we can make that. So we use to value to the function, right? Is the number, right? And need to identify who is here, right? When you write that column, okay, right? Okay, now we write here. Okay, right. So we have a question. Fx equal, fx equal, right? 2x square minus 3x, 2x square minus 3x. Now, subtract who here 0. However, substitute that. Then you substitute 1, 1, 2 times 1, 2, minus 3 times 1, minus plus. Here, then here, C. Now, here, x equal 1. F1 equal 2 times 1 square, 3 times 1 plus 1, 2 minus 3 plus 1 equal 3. Therefore, x minus 1 is okay. Then, using the law of division, right, divide by x minus 1, we can get the expression. 2x times x, 2x square, 2x times minus x minus 2x is minus x plus 1, minus 1 here, minus x plus 1, 0. Therefore, it is equal x minus 1 times 2x minus, right? So, the way we get the factorization. Okay, if we need to get the factors, then definitely. Okay, right. Question number 7. Okay, start with the 3 and 4. 3, 4.